So here's a rather obnoxious table that I asked you to fill out before watching this video. And I had these seemingly bizarre and ugly values of t here. So you wrote down the values of t, and then I wanted to write these down with a common denominator of 24. So if it already had 24 in the denominator, we're good. If it had 6 in the denominator, you had to multiply the numerator by 4 to multiply the denominator by 4. If your denominator was 12, you're going to have to multiply the denominator by 2, so you multiply the numerator by 2. Here your denominator was 3. 3 times 8 is 24. Had to multiply the denominator by 8, so I multiplied the numerator by 8, and so on. I wrote these all with the denominator of 24, getting them all to look the same. And notice I picked these, so these are all apart by 3 pi over 24. So add 3 24ths onto this. This is negative 1 over 24 pi. Add 3 onto this. This goes 2, 5, 8, 11, and 14. So I was adding 3 pi over 24, or pi over 8 on each time. Okay. Then I multiplied by 4. When I multiply by 4, you have 4. We got a little room to write over here.
Go ahead.
If I've got 4 times negative 7 pi over 24, the 4 and the 24, 6 goes into that. 6 goes into, so this 4 goes into 24 6 times, and all the rest end up with the same thing happening. When I multiply by 20, when I multiply by 4, I can write a fraction with 6 on the bottom. Basically, all I did was replace all these 24s with 6s. Now, these are not all reduced, and I'm cool with that at the moment, because I know I'm going to be adding on pi over 6 in a moment. So I don't want to reduce this just to unreduce it a minute later. I'm leaving it with pi over 6 here. Likewise here, I'm going to be adding on pi over 6 in just a second. So it doesn't help me to reduce this to pi over 3. I'm just going to have to unreduce it when I add pi over 6 in a little bit anyway. Okay. Add pi over 6 to all of these. All of these conveniently had a denominator of 6. So that when I added pi over 6, basically I'm just increasing the numerator by 1 pi over 6, by 1. And I get all of these. Then when I reduce these fractions, the sky opens up and angels sing. Because I see I've got what I want here. This is what's going to get plugged into my sine function. And what I want to plug in to my sine, or if this was a cosine function, I want to pull in these multiples of pi over 2. So it wasn't random that I gave you these values to start with on the left table. I deliberately picked these so that when I went through, by the time I was done, when I got to 4t plus pi over 6, I would have my nice multiples of pi over 2 here. Okay. These are nice to plug into sine. So I'm going to plug what into sine? Whatever's in this column. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. These should be fairly familiar to you. If you've got to draw this guy again, do it. Okay? Sine of pi over 2 is 1, or sine is the vertical coordinate. Sine of negative pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. Okay. Finally, I got tired of writing columns, so I didn't multiply by negative 3 and then add 5, because it was easy enough to do both 2 mathematical steps here. Okay. Remember what I'm going to do here. I'm going to multiply this guy by negative 3 and then add 5. So when I multiply this by negative 3, it's still 0. Add 5. Boom. Multiply this by negative 3, I get positive 3. Add 5, I get 8. Multiply this by -3, it's still 0. Add 5, I get 5. Multiply this by -3, I get -3. Add 5, I get 2. Okay. I'll let you do the rest. Actually, you're kind of redundant with these, and I should have a pattern here, a repeating cycle. 5, 8, 5, 2. 5, 8, 5, 2. And you know what would happen if I kept going on. Okay. Now I've got to graph these things. And can you re-aim, or should I erase the middle of my board?
You can go ahead.
Okay. So, what are my values of t? Ultimately, I want to graph t. So my columns are all the way on the left there, t, and then sine of t. So what have I got? I've got these obnoxious multiples of pi over 24. So as I label my axes, each hash mark has to be pi over 24. That means 4 hash marks gives me pi over 6. Two sixths, pi over 3. 3 sixths, pi over 2. Again, every 4 marks, negative pi over 6. Another pi over 6, negative pi over 3. How's my height? Didn't need to do all that. And I want to have room to go to 8. So I'm going to go 4, 6, 2. Okay. What I suggest doing now is putting some guidelines on here. My middle value is going to be 5. You don't necessarily need to do this as much if you've got graph paper as opposed to me freehanding it on here. My highs are going to be at 8. And my lows are going to be at 2. So all my key points are going to be on this dashed line. And they're either going to be at 2, 5, or 8. So they're going to be on the dashed line. My lows, my middles, my highs. And so let me go all the way back here. Again, 1, 2, 3, 4 of these made pi over 6. So each one of these is 1/4 of pi over 6. Pi over 24. I'm going to start at negative 1, 2, 3, 4, 5, 6, negative 7 over 24. I'm getting out 5. I'm in the middle. So 4, 5, 6, 7 over 24. I'm getting out 5 in the middle. Then at negative pi over 6, I'm at 8. Negative 1 pi over 24, I'm back in the middle at 5. Pi over 12, which is 2 pi over 24, I'm down here at 2. At 5 pi over 24, that's 2 24s, 3, 4, 5 pi over 24, I'm back in the middle. 6, 7, 8 pi over 24, also known as pi over 3. I'm peaked at 8. 3 pi over 4 later, I'm in the middle. And how high do we go here? Here's 6 pi over 12. Here would be 7 pi over 12. I'm down low again. So where am I going to go? Middle, high, middle, low. Middle, high, middle, low, and you can keep going forever. Okay. Because I gave you nice, pretty values to plug in here for t. They didn't look so pretty. But again, I'm helping you along here. I rigged this. I gave you values of t. So ultimately, by the time you put them through this machine, right here, your input into the sine would be these nice pretty multiples of pi over 2. So your output from your sine, from the sine part of the function became your zeros, ones, and negative ones, which were then easy to plug into here and gave you your key points from which to graph.